Welcome back, guys. We've spent the last couple of videos talking about different forms of a line and graphing lines, but really what I would like us to do for the next couple of videos is talk about writing the equation of a line. So we're given information about the line and we have to write the equation. But in order to do that, one of the things that's really important for us to do is be able to switch our equations into standard form. Now, if you remember, I told you that there are three forms. There is the slope-intercept. Hopefully you've got these tattooed on your body somewhere by this point because they're that important. Y equals mx plus b. And we have the point slope form. And that is the y minus y1 equals m times x minus x1. And both of these equations are very good for if we're asked to write an equation, right? So if we're saying, if the directions say, write the equation of the line that has these properties, these are the two that we would start with, right? We generally don't choose to graph from the point slope. That's usually not the form that we take. We usually have the slope intercept or the general form, which is the ax plus by equals c, or the standard form. So that's this form right here. So generally what we do is we write equations in this form and then leave it in one of these two forms, right? And so what we're going to end up doing is a lot of switching from these forms into this form. And so I just thought that we would take a couple minutes right now to talk about that so that when we get into the following videos and you have to change that, it's not completely new to you. So, so let's just talk about how you would take an equation that's in slope-intercept form or in point-slope form and convert it into standard form. And the first thing I want to point out, again, we've talked about this a little bit, is just some of the major differences between these two and this one. So the first big difference is that here y is on one side and x is on the other. And in this one, we've got x and y on the same side. The second thing, and this is only a difference here, is that this one has parentheses and this does not. So we want to talk about how we can go from this to this. So if I were to write a list of steps for you, the first thing I would say is get rid of parentheses if applicable. Okay. If you're starting with this, you won't need to do that. But if you start with the point slope form, you will need to get rid of parentheses. So that would be probably the first thing I would do. Now, there will be exceptions to that, and I will explain that a little bit later on, but get rid of the parentheses. The second thing is get the x term. Or get the x and y terms together. On one side. Right, so get rid of the parentheses, that takes care of that part, and then get the x and y terms together on one side. That takes care of the fact that in both of these there's only a y on this side. There might be more stuff, but the x is not there, so we have to move that over. All right, step 3 would be to get the constant terms together on the other side. Step 4, and this is just things that are very specific to the standard form, put x and y in alphabetical order. Whoops, I can't spell while I'm talking. A-L-P-H-A-B-E-T. Alphabetical order. And then 5 is get rid of all fractions. And again, they don't have to be done in this order, but they are all things that have to be done. Oh, there's one other thing. Make sure the coefficient of x is positive. Right, so again, they can be done in varying orders, but these are all things that must happen for us to have something go from slope-intercept or point-slope form into the standard or general form. So let's take a look at an example of something that's in point-slope form. Slope-intercept form. Let's say we had something like y equals 1/2 x minus 3. And we wanted to change it into this ax plus by equals c. Okay, so as we look at our steps, the first one says get rid of parentheses if applicable, and clearly that's not applicable. There are no parentheses here. Get the x and y terms together on one side. So I'm going to take this term right here and move it over. So that would give me negative 1/2 x plus y equals negative 3. Right, get the constant terms together on the other side. This is the only constant and it's already by itself on the other side. Put x and y in alphabetical order. I did that when I moved the x over. So as you're moving it, just put it where you want it to be. Just make sure that if you, for some reason, put it behind the y, that you switch it at this point. This is one that really seems to bother people. Get rid of all fractions. The coefficients a, b, and c must be integers. They cannot be fractions. So we have to clear out the fractions here. In this case, there's only one fraction, so this should be easy to do. We're just going to multiply by the denominator. But if there's more than one fraction, we're going to have to find the common denominator of all the fractions and multiply that by that. This is similar to what you guys have done before when you have solved rational equations. You find the denominator that's in common to all the fractions and then multiply through by it. But in this case, we're just going to multiply by 2. Now, I could do just by 2 and then in a separate step make sure that the coefficient of the x is positive, or I could do this all at once and multiply by negative 2, because then the 2 will get rid of the 2 in the denominator here, and the negative will get rid of that negative here. So we're just going to do that. So I'm going to multiply each term by that. So negative 2 times negative 1/2 is positive 1x. Negative 2 times y is negative 2y. And negative 2 times negative 3 is positive 6. All right, so it's now in this form ax plus by equals c. A is equal to a positive 1, b is equal to a negative 2, and c is equal to 6. Again, not that we really need these for anything, but just in case you're wondering, that's what they are. So we've changed this equation from slope-intercept into standard form. All right, now let's take a look at another one where I put a fraction here. So let's say we have y equals negative 3/5 x plus 5/6. Okay, so when we do that, I'm going to do the same steps that we did before. I'm going to move the x term over because there's no parentheses to get rid of. So this would be positive 3/5 x plus y equals 5/6. I just want to show you what happens if you have more than one fraction here. So we have to multiply through. You could multiply by 2 separate things if you would like to go through and do this on 2 passes. First multiply through by 5 and that will get rid of this, and then multiply by 6 and that will get rid of that. But I'm just going to multiply through once by 30. I'm going to keep it positive because the 3/5 is already positive, or the coefficient of the x is already positive. So as I go through here, again, I'm going to distribute, multiply it through each term here. So 30 times 3/5, the 5 in the denominator will cancel out with the 5 and the 30 to make this 6. So the coefficient will become 18x plus 30y equals, now the 6 here will cancel out with the 6 in here, leaving a 5. So this will become 25. Right? So then we have 18x plus 30y equals 25. So we've taken it from this slope-intercept form and turned it into standard form. Okay, let's look at another equation, but this time let's change from point-slope form into standard form. And these get a little bit trickier. Let's say we've got y minus 3 equals 2/7 x plus 1. And while we do still need to get rid of these parentheses, I'm going to suggest that you get rid of the fraction first, because if we don't do that, let me just show you what's going to happen. We've got y minus 3 equals 2/7 x plus 2/7. all right? And then bringing this over to the other side and adding 3 to 2/7 is just going to be a mess. So we're going to wait until later to distribute that. But so first we're going to get rid of the 7 in the 2/7. So this is the only fraction, so that's the only denominator that we need to worry about. So I'm going to multiply everything through by 7. All right, when I do that, 7 times y is 7y. 7 times -3, -21. This is the part that messes everybody up. If I do 7 times 2/7 times x plus 1, a lot of times people want to distribute this in to do 7 times 2/7 and 7 times x plus 1. Do not do that. This is 3 things that are being multiplied together. Remember, distributive properties, formal name is distributive property of multiplication over addition or over subtraction. This is not distributing over addition or subtraction. This is distributing, you would be distributing over multiplication, and there is no such property. So when you have 3 things multiplied together, you just choose one pair to multiply together, and then the third guy stays out. So obviously, this would be the good choice. We chose 7 specifically so it's going to cancel out this denominator, right? So we're going to group these two together. 7y minus 21 equals 2 times x plus 1. Right. If you don't like the explanation I just gave you, think back to when you were doing just regular multiplication. Think if you had 2 times 3 times 4. You don't do 2 times 3 and then do 2 times 4. You associate 2 of them, get an answer, and then multiply by the third one. All right, so then you would get 24 here. You would not do 2 times 3 and 2 times 4. You pick one pair to multiply together, you get an answer, and then you multiply by the third thing. So that's what we're doing here. We're picking 2 together to multiply. I'm very specifically picking these 2 because I want the 7s to cancel out. So again, the reason I'm making such a fuss about this is because I do not want you to distribute that 7 in there and also multiply it by the coefficient. Usually we just multiply by the coefficient. Okay, now, again, we're back to our list. So we've actually started down here, get rid of all fractions, but now we still have to do this step of getting rid of the parentheses. So let me go through and do that. So this is 7y minus 21 equals 2x plus 1. So much easier to do this because now there's no fractions anymore. We just get to move things around and they're all nice integers. So I'm going to move the 2x to this side so it becomes negative 2x plus 7y minus 21 equals 1. So I now have the x and y together on one side. Now I'm going to move the 21 over to the other side to get the constant with the constants alone on the other side. Now, you might be wondering, do I have to do that in 2 separate steps? No, you don't. If you want to move the 2x and the 21 all in one step and just go from here to here, go for it. That's fine. All right, x and y are in alphabetical order, but the coefficient of the x is not positive, so we're going to multiply everything through by -1. So this would become positive 2x minus 7y equals negative 22. And that would be our final answer. All right, hopefully I have time to do one more with you. If I cut off in the middle, I'm sorry. Okay, let's say we have y minus 3/5 equals negative 5/4 times x minus 2/3. All right, I'm very specifically picking really nasty numbers here. All right, so we want to get rid of all the fractions. Again, do not distribute that through first because it's going to be a mess trying to find common denominators here. So we're going to go through and we're going to multiply by one number. Again, you could do this in several steps if you want to, but I think the easiest is to go through one time and multiply it by a number so that all of these will cancel out eventually. So I'm going to look for the common denominator of all the denominators here. So 4 and 5 would be 20, and 20 and 3 would be 60. So I'm going to go through and multiply through everything by 60. All right, and again, remember I multiply it by each term. Because these are multiplied together, this is considered one term, so it gets it one time. So 60y minus, and then the 5 that's in 60 will cancel out and leave a 12, and then 12 times 3 is 36. equals, right? I'm going to multiply these two together now. Again, I'm not multiplying it by that. The 4 goes into 60 15 times, and the 15 times negative 5 is negative 75. All right, now you might think, well, that was an epic fail, Mrs. Taylor. We still have that 3 there. It's okay, because watch, because now at this step, we're going to distribute through. All right, we're going to distribute that negative 75 through to the parentheses. And we'll get 60y minus 36 equals negative 75x plus the 3 goes into 75 25 times, times the 2 would be 50. Okay. Now let's get the x term over to the other side. So then that's 75x plus 60y. I'm going to do this at the same time, move the negative 36 over to the other side as a positive 36, so that gives us 86. And that would be your final answer. Okay, if you need to go back and watch these a couple times, please do, because this is really important. And again, these next problems that we're going to do require a lot of steps. And so I need to make sure that you are good with all the steps. So just go back, make sure that you take some notes on this. And then as we go into the next one, I will keep reminding you. Okay, bye.